So example number 3, solve, then check your answers using graphing technology. So for this one, I'd rewrite it as a base of 2. So 2 to the power of 4 replaces 16, and then you have 2k minus 3. And then on the other side, 2 to the power of 5 replaces 32, k plus 3. Distribute, distribute. So 2 to the power of 8k minus 12 is equal to 2 to the power of 5k plus 15. So what we're doing is we're getting rid of the bases because they're equal, which means that the exponents are equal. Bring the 5k to the left side, bring the negative 12 to the other side. You'll get that 3k equals 12 plus 15 is 27, divided by 3 on both sides. K equals 9. Now, with this one, the window is actually going to be quite large, and I'll show you why. So if I substitute k as 9 into the left side, I want to see what y value it's going to equal. So if I put 2 times 9 minus 3, and I'm going to put that in my calculator just to show you the value. So I'm going to go 16 to the power of 2 multiplied by 9 minus 3. I get something massive. I get 1.15 times 10 to the power of 18. That's scientific notation. That's a large answer there, right? So that means that my window is going to be quite large. So I'm going to find for my y value a number around that. I'm going to go from 1.1 times 10 to the 18 up to 1.2 times 10 to the 18. So that's going to be the window that I'm going to use for this. And for my x, I know my answer is 9, so 0 to 10 would be sufficient, going up by 1. So when you graph this, you might not see the intersection, but still go second trace number 5 intersection, and you'll find that the answer is still number 5. If you do this graphically, checked, and it works. Example number 4, I'm going to show you how you can use systematic trials to figure out the value. But of course, your graphing calculator would be sufficient. So I know that 5 as a base is 5 to the power of 1. So I want to write 5 to the power of something gets as close to replacing 1.08 as I can. So that's what I want to find. So what I'm doing is I'm just plugging in different values until I get kind of a pattern. So I first tried, 5 to the power of, I did 5 to the power of 0.1. So 5 to the power of 0.1 equals, I got 1.17, which is close. It's close to 1.08, but it's not there yet. So I keep going lower and lower. So what I did next was I did 5.0.05. I took less than 0.1 and I plugged that in as the power, and I got 1.08. So that's actually really good. I'm going to use this value to replace 1.08. So it's really trial and error. You're plugging in numbers 5 to the power of something to see what could replace 1.08. So I'm going to put 0.05 here. And then I'm going to distribute that 0.05 into x plus 2, and then leave 1 on the left side because the 5s will cross off. So it's going to be 0.05x, and then we're going to have to go 2 multiplied by 0.05, and I get plus 0.1. We're going to subtract 0.1 on both sides. You get 0.9. is equal to 0.05x. Divide both sides by that, and let's see what we get. I get about 18. So let's see graphically, it should be 18. So graphically, if I were to do this, if I were to put y1 into as 5, y2 as this, you should find that the answer is about, so I'm going to do that with you guys actually. So I'm going to clear whatever I have there, put 5 there, put 1.08 to the power of x plus 2. Graph it, but remember the window, I'm going to have to adjust it from my previous example. I'm going to use the standard window for this one because my y-coordinate, I'm just trying to see if it equals 5. So window, go from 0 to 10. Ah, it's having issues. Yeah, okay. So this isn't working for me right now. Let's reset this. Okay, so I'm just going to do on my own calculator in front of me right here, and I'll just tell you what the answer is going to be. So I put y1 as 5, I put y2 as 1.08 to the power of, in brackets, x plus 2 if you have an older style calculator. My window, standard window would be enough, or from 0 to 10, and then from negative 10 to positive 10. For the x though, the standard window, I'm actually going to have to go higher. Since I knew that the answer was 18, let's go up to 20 then. So we're going to graph it and find the intersection because 10 would not have been enough if I were to do this graphically. And then I'm going second trace, number 5, intersection. I should get that the value is about 18.9. So this was just an estimation. So this systematic trial is a good way to approximate what your answer is, but it's not going to be exact. This one is more exact with the graphing calculator. Okay, so this is the correct answer, 18.9. So I just wanted to show you that trial and error, because of the rounding that happens to get this, there was all these decimal places here that I didn't include. That does change your value quite significantly in this case. So here the answer is 18.6. Example number 5, determine how long $1,000 needs to be invested in an account to earn 8.6% compounded semi-annually before it increases to a value of $14.90. So we're talking about interest. So we're going to use that A equals P, 1 plus I. Since we have compounding, we're going to divide by C, and then we're going to take our N value, and we're trying to find out how long, so that's what we're trying to solve for is N. So we know that we're trying to figure out when $1,000 will equal $14.90. And then we're going to go 1 plus our interest. We're going to change it to a decimal by dividing by 100. And then compounding, divide it by the compounding, which is semi-annually, which is 2. We're going to solve for N. So you're going to go y1, y2, put that in your calculator. Let's simplify and see if we can use a common base method for this one, but it would be tricky. So I kind of recommend you do graphical in this case because I have this 1490, so you'd have to do a bunch of trial and error to figure out a base that would work for that. So I highly encourage graphical solutions for this one unless they tell you a certain method, but I would give you better numbers than these ones for the graphical solution. So 1490 equals 1,000 in your calculator, put 1 plus 0.083 divided by 2. And you should get that this should be 1.0415 to the power of n. So like I was saying, these numbers, they don't look great, right, when it comes to finding a common base. So I would do y1, y2, find the intersection. Okay, so that's what I'm going to do to my graphing calculator. So I would go 1490 into y1, 1000 times 1.0415 to the power of x. Change my window. We know that the y's will have to go maybe from like 1000 to 1500. The reason being, as long as I can see 1490, that's all that matters in this scenario. And then we know initially it's going to be at 1000. It's going to grow. Actually, it's going to grow from there. So it's increasing in value. So we also know that we're talking about semi-annual periods. So let's go from 0 to 20 at first, because this is going to be like how many half-year periods will it take to get there. And then we'll graph it and see if we see an intersection. And I do see an intersection. So I'm going to go second trace, number 5. And I'm going to press enter 3 times until I get the intersection, which is occurring at when n equals 9.8. It says this is going to be 9.8 semi-annual periods. So this is not in years, because you have to use your compounding, and that's what the answer is going to represent. So semi-annual periods here. Number 6, it says a bacteria culture starts with 2,000 bacteria. Oh, with the previous one, before I go to example number 6, if they wanted to know the years, now this is just an extra question that I'm adding, but if they wanted years, what you would do is you would take this number, and since you had to divide your interest by 2, you would have to divide this n by 2 to go backwards. So 9.8, if you divide by 2, it's going to be approximately then 5 years. So just to show you how to get that before we go on. Example number 6, though, what you want to do is you want to take y equals 2,000. So that's what you start at. That's the initial growth. And this one's saying that you're going to double. So that is your C value, or your base. 2, it's going to multiply by 2 to get to your next value. Now, it says it doubles every 0.75 hours, and that's going to be your p-value. So your p-value is 0.75, and then it's t over p, right? So t over p, which is 0.75. So this is your expression that represents the bacteria growth. What they're saying is, after how many hours will the bacteria count be 32,000? So let's put that into y. Okay, so I'm going to divide both sides by 2,000. So 32,000 divided by 2,000 equals 16. And we have 2 to the power of t over 0.75. These are going to be nice numbers if we work with them right here, right? So if we have 16 and 2, we can write them both as bases of 2. We can write 2 to the power of 4 replaces 16. And 2 to the power of t over 0.75 is what we originally had. Now the bases can cross each other off, leaving us with 4 is equal to t over 0.75. Lastly, we can multiply both sides by 0.75. So 4 times 0.75 gives me 3. And don't forget to include the units. So we're going to say, therefore, it's going to take 3 hours, right? So therefore, 3 hours. Okay, so that's pretty much what you do here. It was really nice, so that's why, for example number 6, I chose to use that common base method versus example number 5. If I did try to do the exact same method I did for example number 6, it wouldn't give me a nice number. As you can see, we didn't get a whole number, we got 9.8, so that's not a whole number, so that's why it's more difficult to do common base method, and so I really recommend you do the graphical method in that case there. Okay, so that's it for lesson 7.3. And to practice, you should do your homework and make sure you try this row game. So column A and column B, if you try them